Okay, in our continuing quest to review for the final, today's part is called quadratics B, and the one after that, which is higher degree polynomials. So this is an intense one. Partially, it's because this is the toughest stuff that we did, except it wasn't on the cumulative we just had, okay? So it's kind of been forgotten, and it was some of the toughest stuff we did. All right, so some thoughts. I bet you only 2/3 of you will remember the formula that tells you vertex. The vertex is x equals, don't say it, it's a formula. It's easy to forget. Hint, if you know one big formula, you actually know 3 formulas. What's the one big formula? General formula? There's no such thing. Okay. X equals what? Negative b plus or minus the square root b squared minus 4ac all over 2a. All right. Does she have a different way for that?
They would just slam books on the table and then be like
Oh, yes. I know what you're talking about. Yes. Her school taught it in a dirge. Pausing for a second. So, this formula, no matter what song you use to memorize it, has got this buried in it. That comes up today. It's called the what? Discriminant. Very good. And that, if it's less than 0, it would be negative, and you can't have square roots of negatives, and therefore there'd be no roots. What if it's bigger than 0? Then there's 2 roots. What if there's the weird case where it's actually equal to 0? 1 root, and if this is equal to 0, think about it. That cancels out, and it leaves you this, which is the vertex formula. So if there is only 1, it's the vertex. And the vertex is at negative b over 2a. All right, so moral of the story, there is a formula for the vertex. You need to know it. And it's negative b over 2a. And I can't erase the board. Ugh. Okay, so I'm going to just work around that spot. So we have negative b over 2a. How do I do that? Ooh, I could do complete the square instead. Do you remember that? I'm going to show you both methods. All right, here's the x equals negative b over 2a way to do it. You need to know this. This will be on the ACT. This will be on your test for the final. This will be in second semester. You need this negative b over 2a formula. It's a big deal. All right, what's negative b? It's negative of negative 8. So it's 8 over 2a, which is 2 times 1, which is 2. So x equals 4. But that's not a vertex. Vertexes aren't just like 4. It's 4 comma something, right? So then you go, okay, I want a vertex that's 4 comma, and then how do you find the rest of it? Plug it in. Take the 4, you plug it in here, you plug it in here, and you get 16 minus 32 plus 12. Save me some time. What is it? Negative 4. Awesome. Now that I have the vertex form of the equation isn't so hard. That's pretty easy, in fact. And I just say it's x minus 4. Notice I changed this to opposite of what I would think because it's on the inside. Does that ring a bell? Remember doing that? Okay, so the negative b over 2a is one way to do it, but do you remember how to use complete the square? I'm going to pause for a second. Okay, so we have complete the square. I'm going to rewrite my problem here because I kind of scribbled over it and I can't erase. Can't explain that right now, but technology just happens sometimes. All right, so how do you complete the square? Do you remember this deal? Do you remember half n square is involved? Does that ring a bell? All right, so I'm going to go like this. Y equals x squared minus 8x plus something and minus something. And my 12 is still here. It hasn't gone away. Plus 12 at the end. Now, what's the plus and minus thing? They're the same number. And I add whatever number would go here and work out well. And in this case, it's half n squared of the 8. Well, what's half of the negative 8? It's negative 4. And you square it. When you square anything, it becomes positive. So these are always positive. 4 squared is 16. And that one's plus 16, and the other one would be minus 16. That way they cancel each other out. Otherwise, other than the black writing I just wrote there, everything else I wrote in red is the same as we had before. Okay, now this part factors, and if you can factor it, you should. So you go y equals x minus 4 times x minus 4, but I'll just say squared. And then this part goes together and makes minus 4. And look at that, it's the same thing I had before. I have to say, I think completing the square is pretty slick. It gets you an answer pretty quick. Any questions about complete the square, the simple kind at least? All right, there is a more complicated kind of complete the square, and that's where the number has to be factored first. See this negative here? When you have a negative in front of a quadratic, I just always recommend you factor that off. So let's do that right now. Negative 1 comes off, and then we have x squared plus 12x plus 27. That gets rid of my negative, and now I might be able to factor it, because 9 times 3 makes 27, and 9 and a 3 makes a 12. See if you can factor that. Leave the negative 1 there. Some people just let it drop off. You don't want to do that. Pretty sure that's it. Raise your hand if you had the same thing as me. Or am I screwing something up? Help me. Oh, so far, I'm not doing the complete the square thing. I'm not doing that right this second. I'm just factoring it. You know why? Because they're going to ask me for the zeros. And this tells me the zeros. Okay? Now, it also does want vertex form, so dang, I'm going to have to do the vertex. Honestly, instead of making you learn to do really complicated complete the squares, I don't think this was too bad. But the kind where you have to factor, I think it's better to just use the negative b over 2a thing. So let's do it. What's negative b in this equation? 12. And it's x equals 12 over 2 times negative 1. Final answer, x equals what? Negative 6. I already know the beginning of my vertex form. How do I figure out the rest? Well, I already know x is negative 6. I just need to know what y is, right? So you take the x, you stick it in. It's a little bit of a pain here because I got negatives all over the place. Negative, negative 6 squared minus 12 times negative 6 minus 27. Get all that simplified down and we'll have the answer. Somebody's probably already got it. Apparently not. Okay. Remember, a calculator will be allowed in this test. Why don't you grab one right now? Since you've got to use one for the final, might as well use one now. If you want to borrow one, I have extras up here. I want to warn you that when a reserve teacher is here, I can't promise you that they're going to have as many calculators as I will. I'm going to leave them a few, but I'm not going to leave them my entire stash of calculators, just for fear that $100 bucks a calculator times like 9, it'd be $900 worth of calculators could disappear when I was gone. That would really hurt. So. What do you get? 9? Can anybody verify 9? All right, awesome. So then, my x was 6, my y is 9, and therefore this means plus 9. And I got my vertex form, except, oh, I just lost a point. Who's smarter than me? Yes? Yes, because see how there's a negative in front? There's a negative right there. Oh, easy to forget the negatives. I would say there are some of you that have single-handedly moved from an A to a B in this class based on negative mistakes. Seriously. And some of you know you've moved from an A to an A minus just from negative mistakes. Happens all the time. Try to catch yourself on that. All right. What is the vertex? Well, that's easy. Now they got vertex form. Maximum or minimum? I think a picture is worth 1,000 words. I'm going to graph this thing, and I'm going to see that negative 6,9 is like there. Probably should be up a little bit more. Let's see if it'll let me move it. It does. Okay. Now I'm going to graph it and say, oh, there's a negative in front, so it's upside down, right? So this tells me a lot. Since it's upside down like that, then that was a maximum point, not a minimum. And it also helps me figure out the domain and range. All right, so some morals of the story. We've already had, if you can factor it, you should. We've had, here's a formula that's really important that's got two other formulas in it, the discriminant formula and the x equals negative b over 2a formula. A lot of things to know. If you're not taking notes, you're hurting your final score right now. It could really be helping. Okay. I want to move down the page a bit. Do you have any last questions before I scroll this thing down? All right. Then, these are all the same. So, vertex form, I personally would, if I can't just do a simple complete the square, I'd use negative b over 2a. Don't forget, it's x equals negative b over 2a. Because otherwise, people do negative b over 2a, and they get this number like 7, and they're like, I don't know what it is. X equals negative b over 2a. And then you know you got x equals 7, and then hopefully you're smart enough to know, oh, I can stick it in to get the y. All right. I'm not saying the answer is 7, by the way. All right, enough about that stuff. Let's talk about this. How do you solve a quadratic? It's that big formula we just wrote out and sang a second ago. If you use that whole formula, you're finding the roots, the zeros, the x-intercepts. And simplified radical form means something like this. 2 plus and minus the square root of 7 all over 8. That's simplified radical form. You leave your answer like that. Okay. If they want a decimal form, that means you have to grab your calculator and actually figure out what the square root of 7 is, and then do 2 plus that, and then divide by 8, and then do 2 minus that, and divide by 8. That kind of thing. Again, I totally made this one up to show you what kind of answer you wanted. All right, moving on. What's wrong with number 10? The very first thing you should do on number 10. Subtract 15. Why? Because you want to set it equal to 0. Good. All right, moving on. On this one, it's about D, the discriminant. Do you remember if the discriminant was negative, you wouldn't have any answers? Because you'd have a square root of a negative. Hopefully you can tell which of these three pictures is the discriminant being negative. Which one do you think? B, because that's the kind that won't have any answers because it's not touching. How many answers would this one have? 1, and hopefully you know what that means about the discriminant. And then this one's got 2 answers, so hopefully you know what kind of discriminant does that. We talked about it already. If you have to, go back and watch this video. And earlier on, I talked about discriminant. All right, how about this one? On this one, a calculator is useful. You've got your calculators out, so I do want to take just a moment to talk about the 2 different ways you could do this. Some of you are really good with your calculators, and you could know how to graph this. I think you all can type that in the calculator, can't you? And you could graph it, and it would look kind of like this. Do you get what I'm talking about? Okay. But not many kids know how to find this spot, which is called the vertex, with the calculator. Now, if we wanted to use the method I just showed you, it is the simplest thing, and I'm pretty sure that's the way Mrs. Petzold had taught you, which is just use x equals negative b over 2a. But I want to show you one other way that's kind of techie. And you guys are pretty good at using things like the calculators or computers, more than the average generation before you. I bet you'll pick this up pretty fast. So, would you please type this into your calculator, and I'm going to tell you what you can do next. Okay, once you have it so that you can see your parabola, and you know this is the important spot, follow this key sequence. Ready? Second, and then you're going to hit the trace button, but above the trace button, what you're really doing is calc. You get what I mean? When you hit second, you're going above the trace button. So second, and then trace gives you calculate. On the calculate menu, one of them is maximum. One of them is also value, and I'm going to show you that in a minute. But anyway, one thing at a time. You should now have, after you've hit maximum, Mr. H, please listen. Once you've hit maximum, now you need to follow its directions, and it's asking you questions. What's the first question it asks you after you hit maximum? Left bound. You go to the left of this and hit enter. Like there's a little spider you're moving around, right? You move that thing until it's to the left of the maximum and you hit enter. Now you go to the right. It says right bound, right? And then you go to the right side of your maximum and you hit enter. That puts in these little carrots like this on your screen. And it's saying you want to go, on this side of this line and on the other side of the other line. And the last thing it says is guess. You move the little spidery thing to right here at the maximum thing and you hit enter. And now it'll tell you exactly what the maximum is. You don't have to use negative b over 2a. You don't have to go figure out what the y value is because it's all there. Who was successful on that? Raise your hand if yours worked. Okay, I'm noting that's only about half the class. Some of you weren't trying. Some of you were lost. Ask the kid next to you if you can how to do that. Mr. GL, would you please read me the x of your maximum?
I got like 0.4591841.
Okay, good enough. And then for the y of the maximum?
10.333162.
Now, this is important that you are able to interpret that. That is seconds. That is meters. Do you get that at about a half a second, this thing reached its maximum height, which was about 10 meters? Do you get how it gives you two answers at once? All right. If you need me to show you that process one-on-one, I can. But again, it was second. The trace button, which gives you calculate, maximum. You go to the left of it, you go to the right of it, and you go right on top of it. All right. Now, let's do one more like that. Get it back so you got the graph and you can see your parabola and you can see the top of your parabola. Everybody got that? Okay. Doesn't look like you've got that. Oh, I'm sorry, I couldn't see it. All right. Then, would you please try second calculate value? It's the same exact thing we just did, except don't choose maximum, choose value. As soon as you hit value, it brings up an X with a blinky. It's trying to get your attention with that black blinking cursor. You see it? It's saying, what is the X? And what is X? Is it like number of chickens? What is X in our context here? It's time. It's seconds. So when the question asks you that there's like 2.1 seconds, that's where you'd put it. Okay? Let's see that in the context of this question. Look at this first question. How high is the object after 1.3 seconds? You just type in 1.3, you hit enter, boom, you got the answer. All right, now some of you are going to think that's cool. Some of you are going to think, I never want to do that again. That's fine. You don't have to. What could you do instead? You stick the 1.3 right there, where it's a time, right? So you put it in for t. You can stick the 1.3 in there and there, and it'll get you the answer too. All right, I just want to take a little minute, even though it's somewhat painful, to get you a little better at using your technology, because computers are powerful. You can bring a computer, i.e. this little graphing calculator, into the test with you, but you can't use your iPad. So I just wanted to help show you how to use your little handheld computer there. By the way, the thing that you have at your desk there, that graphing calculator, that is just a little less powerful than what they used to put a man on the moon. Okay, so it is not nearly as good as your iPad, which is way more powerful than what they used to put a man on the moon. But this is pretty dang powerful. It can do programming. It can do all kinds of cool stuff. So that graphing calculator, it's good to know a little bit about it. Yes, ma'am.
On the test, If you want to use a graphic calculator, do you still have to show work for this problem?
Good question. You always have to show work, but what you would say is a little sketch of what you did on your calculator, and then I would say use second trace or something like that. So if you just say what you did, then I'll trust that you used the calculator for it. Yes? That's how I do them. But don't just forget all the formulas. Those are handy for other problems, like negative v over 2a. That's the vertex. And I just think it's easier to use the calculator. But I'm pretty good at the calculator, and I know some of you are like pretty bad at it, and if you don't want to use it, don't use it. It's fine. I just want to show you how you could. Okay. Let's move on to a different kind of problem where it says, when will the balloon hit the ground? If I'm making a sketch, because the picture's worth 1,000 words, do you get that when it hits the ground is right there? That's called the x-intercept. We have a formula for that, right? Now, there is a way to do this one on the calculator too, but it's kind of complicated, so I don't think it's worth it. For this one, I just use a quadratic formula. It is called the zero, but it's a little complicated. If you're into this kind of thing, you can use second trace zero and try to figure it out. You go to the left of the zero, you go to the right of the zero, and you go right on the zero. It's kind of like that other method, but I just want to remind you, all you got to do is quadratic formula for this kind. Okay, I have one more worksheet to go over. Believe me, I'd like to stop, but there's so much on this next worksheet that's going to be handy too. We need to talk about it. It's going to really increase your chances of doing well in the final, okay? So I'm going to pause for a second while I pull up the other worksheet. So this is how that last worksheet looks. It's called Higher Degree Polynomials Review. This is the one where you had to be an algebra ninja to be able to do this test. Tons of factoring. You'll even have to know how to do synthetic. You have to know how to do long division. Well, actually not. Yay. Thankfully, you can get away with just synthetic. In pre-calc, when you hit that next year, you'll have to be able to do long again, but as long as you can still do synthetic here, you'll be okay on this final. All right, so one thing at a time. This first question is our R2 level. Easy question. Try it without me. See if you remember how to do those factors of this divided by the factors of that to see what the possible factors are. They're not asking you to factor it. They're asking you what possibly could be the roots. You know, like what could go in the little box when you do synthetic? Like what could that be? Okay, did you say, I call it F-con over F-co. Factors of the constant over factors of the coefficient. The constant ones were 7 and 1. Raise your hand if you knew that. Awesome. And the coefficient ones were 2 and 1. When you actually divide them, you get, don't forget the plus and minus, 7 over 2 and 7 over 1, which is better written as just 7. And then 1 over 1, which is just 1. And then 1 over 2, which is 1/2. I don't have any law that says they have to go in order from smallest to biggest or anything. There you go. Now, do you get, if I was supposed to factor this right now, that you would, in the old days, have had to just keep using synthetic over and over until you found the right one? I'm going to show you how to use the calculator, and you won't have to do that. It's pretty cool. All right. So let's say that this thing could either have 7 over 2, 7, 1, or 1/2. It's got to be one of those. If you graph it, you see where it hits the x-axis, and that's the 0. So go ahead, type this into your calculator. This is not what the worksheet's asking. They just wanted this, and we're done. But I'm just trying to show you for the test, if you need to know which one is the root, don't test 17 things. Graph it. Once you graphed it, you'll see, oh, looks like it's touching at 1. Or looks like it's hitting the x-axis at 1/2. or 7, or negative 1, or negative 7. Now, is it possible that a function could not even touch the x-axis? Yeah. Then none of those are the right answer. And at least you wouldn't have wasted your time testing them all. Has anybody got it graphed successfully? You can see it on your screen. Do you see anything touching the x-axis? Then it's got to be one of those 4 things. Does it look like it's more like 1 or 1/2 or 7 or 3.5, which is 7 over 2? Positive 1 or negative 1? Looks like negative 1. Can anybody verify that it touches at negative 1? Cool. Do you get, I don't have to check them all with synthetic then? I can just know that negative 1 works. And I'm going to do a test of this to make sure he's actually right. 2, 5, negative 3, 7. Draw the line. Drop it like it's hot. Multiply. Add. Multiply. Add. Oh, negative 6, sorry. Multiply. Wait a minute. What happened? Did I do something wrong? 5, negative 3. Oh, nasty. Look at that. Oopie. What does 5x and negative 3x make? 2x. Sorry about that. Yeah. I'm sorry. I screwed that up because I didn't add those together. All right, let's go down to a different problem and use that same technique. Take a look at this one, number 2. And the test will be like this, where it doesn't say, you must use this method. So how are you going to factor it? I personally am typing this into the calculator, and I'm going to see where it touches. Then I'll know that's the root I want to use to factor it. So there's usually a kid with fast fingers. Which one was the root? Was it negative 2, 2, negative 1, or 1? 12-minute warning. I'm hearing negative 1. Can anybody verify that? Was it negative 1? Okay. All right. Then I'm putting negative 1 here. 1, 1, 2, 2. Draw the line. Drop it like it's hot. Multiply. Add. Multiply. Add. Multiply. And if it came out to 0, it's pretty unlikely that that's an accident. That's probably right. So therefore, I factored it. And let's see if it's whether it's factored all the way or not. Because that becomes the other issue on this. So many kids will get it factored, and they'll either forget a factor, or they won't have factored it all the way. Notice how I did that? That's the constant, that's the x's, that's the x squareds. So, x squared plus 2. Cool. Can you factor that more? Only if you're an algebra ninja. I don't know if you got taught this or not, but does anybody know that, here, I'm going to just show you can factor this if you use i's. Did anybody ever do that with you? Oh, yay. I think I might have done it with you. All right. Do you get if it was like x squared minus 16, it would factor to x plus 4 and x minus 4? Does that ring a bell? Okay. So this is like that, where we use the square root of 16 and we put it here and here. Well, this just happens to be a 2. So we use the square root of 2 and the square root of 2. That's just like with the 16. It's just the square root of 2 doesn't work out nice. That's all. And then, because this is a plus right here, we need to use I. Because bringing in an extra I means you'll have an I squared, which will give us the extra negative 1 to make it work. Now, some kids are going, what? This seems like it's all new. You do not have to factor things like that. If you do, it means you're extra smart. You know, you get the street cred from Mr. Server that, wow, this kid knows how to do that. That's cool. And you also have the imaginary solutions already done. Do you get what I'm saying? Negative I root 2 would work if you stick it in that side. And the other one's positive I root 2. Hey, I got my imaginary solutions done. So if you can do that factoring, you've got your imaginary solutions. If you can't do that, if you're going to say, Mr. Server, I will not learn that, then just take this, x squared plus 2, and set it equal to 0. X squared equals negative 2, square root, and you're going to end up with the same thing, except you have to do this whole absolute value thing, and then you got your two answers. Negative I root 2, positive I root 2. Yes? That negative 1 at the very beginning happened because we put this in the calculator, and we were able to tell that it touched at negative 1. When I say touched, when we graphed it, it looked kind of like that, and that was at negative 1. Okay? That's what I'm trying to show you, some new tricks with the calculator that can help you on the final. And again, you don't need to use any of these tricks. It's just like the ACT test. You don't need to use your calculator at all. But if you can, you'll have a little advantage. All right. This one is just plain old-fashioned factoring. Just plain old-fashioned 2 sets of parentheses. Number 4, this one's got an x in everything, and it makes it seem really complicated. Just factor that x out, and then it's normal factoring again. Okay, number 5 seems like a beast. Can you imagine all the possible factors of 160? That little trick I just showed you about graph it and see where it touches the x-axis could be really handy on this kind of question. You can say, oh, 5 works for sure. And then you can go like this. And I don't know what works for sure, so it's not 5. I just made that up. Unless I got really lucky. All right. Okay. Don't forget about divide and conquer. That's this kind. Remember how you can break these into 2 parts and factor out the 3x squared? All right. I know your brains are pretty much cooked, and mine is too. Still, that's enough for today. Remember your job for the next couple days. For the next couple days of weekend, yay. But you're studying for the final. So basically, if any of this stuff struck a nerve like, oh, I'm really bad at that, I better go practice that, that'd be smart. Do the practice worksheets, or take notes on a video, take screenshots of what you do, and then all you have to do is go into your pictures, add a picture, and then when you do the submit on that day of the final, you're going to drop all the pictures of the screenshots of this, what you did. And you can impress me with, like, I did 23 pages worth of practice. Not saying you have to do that much, just saying put in what you did. Because some of you have been almost like doing a senior slide, and you're not even seniors. So I can tell you're probably not going to review very much for the final, and it's probably not going to go well, and I'm not going to have much mercy because you're not trying. Others of you are working really hard and trying to show I'm really committed to getting a good grade. I'm more likely to give it to you. And this is one way you can prove it to me. Okay? And when I'm gone, don't forget you can still email me when I'm away on a trip. I'll still get your emails. I won't be mad that you bothered me on the trip or something. That won't bother me a bit. I care about you guys. And so when I come back, I'll have a couple days to compile grades, actually grade your finals and stuff. But you guys can't even see your grades for a while. They shut the window off so you can't obsessively look for your finals grades. The window gets closed so nobody can even look for a while. Then about, I'd say 4 days after we start school again, poof, the window will open up and you'll be able to see all your final grades for the semester. All right. You can just wait. Hopefully you will be not thinking about this. You'll be done with your finals and you will be thinking about other things, relaxing, having some fun. All right. No, next week is not spring break. That's a long time from now. There is a 1 day off.
It's 2 days.
Guys, oh, that's right. You guys have 2 days off. I have to come back to work, but you guys have, I got 1 day off like you. Everybody else has got another day off. Okay. That's all I got for you for today. Make sure you are still studying, and you're going to Dropbox that on the last day, the day of the final.